In this video, I'm going to develop the formula for the surface area of a surface, of a 3D surface. So I have this 3D surface. You can see that it's colored in a light blue. Z equals f of xy, where f has continuous partial derivatives. Okay, for the development of this formula, to keep it simple, we're going to assume that the surface is above the xy plane. F of xy is greater than or equal to 0, just means it's above the xy plane. So we have this domain D, okay, of f. We're going to make that a rectangle. Then what we're going to do is we're going to divide D into subrectangles R sub ij. Each of those rectangles is going to have an area, delta A, equal to delta x times delta y. Okay, so if you look at the picture and you look at R sub ij that I colored in yellow, delta A, if you look at the one side of that rectangle, go to the left, you see that that's delta x. Then if you look at the other side of the rectangle, go straight up and you'll see that that is delta y. If x sub ij is the corner of R sub ij closest to the origin, so you see that I labeled it there, we're going to let P sub ij be the point directly above x sub I, y sub j. So the coordinates of that point are x sub I, y sub j, f of x sub I, y sub j. Okay, so that's straight above. The tangent plane, which I colored in pink, to the surface at P sub ij would be an approximation to the surface near P sub ij. So therefore the area delta T sub ij of the part of this tangent plane that lies directly above R sub ij is an approximation to the area delta S sub ij of the part of the surface that lies directly above R sub ij. Thus, the sum, delta T sub ij, is an approximation to the total area of S. And this approximation will improve as the number of rectangles increases. Therefore, we define the surface area of S to be the summation of the areas of these tangent planes when m and n go to infinity, from j is 1 to n, and I equals 1 to m for I. Now I'm going to come up with a formula that's going to be easier to compute. Okay, so bear with me. We're going to go to the next slide. Okay, so you can see why I didn't want to spend our Google Meet doing this derivation, because it's very long, all right? So now we let these vectors A and B be vectors that start at P sub ij and lie along the sides of the parallelogram with area delta T sub ij. Okay, so you can see the picture to your left. A long while back, we developed the formula for this area, for the area of a parallelogram, okay, as delta T sub ij is equal to the magnitude of the cross-section A cross B. You also need to recall from section 14.3 that the slopes of the tangent lines through P sub ij in the directions of A and B, respectively, are the partial with respect to x and the partial with respect to y. Therefore, vector A is delta x times I, times vector I, plus the partial with respect to x times delta x, all right, times vector k. And likewise, vector b is delta y times component times j, plus the partial with respect to y, x sub y sub I, times delta y times vector k. Okay, so that's in the z direction, as you know. So A cross B, I wrote out the matrix, and I got the cross product, which we've also learned how to do earlier in the course. So the cross product, you have, all right, let me do it in light pink. Okay, as you know, when you're finding what you're multiplying I by, you're going to do this times this minus this times this, okay, which gives you this. Okay, then you cover up this j column, and then you do your delta x times this whole thing minus this, and that's 0. Then you go to your k column, and you would just get this minus that. Okay? In the middle part, as you know, it's minus that. Okay? So there you go. Or you could reverse the direction like we did way back when. So now you take this and you factor out the delta x, delta y. So you end up with this, right? And we know that that is just delta A. Okay, therefore, all right, we have that delta t sub ij is equal to this cross product, A cross B, right? The magnitude of the cross product. Well, I just got the cross product, so the magnitude of that, you don't need the negative because you're squaring it, would be the partial with respect to x squared, the partial with respect to y squared plus 1, the square root of that, times delta A. Okay, so therefore, if we take the first part from the previous page, that's going to be equal to the limit of this part as m and n go to infinity of these sums. And then by definition of the double integral, we get that the surface area is equal to this variable formula here. And then we can replace that with this. So that is where that formula comes from. All right, I hope this helped you. Thank you.